Hello and welcome back to Everything Boats with Captain Frank Lanier, where we discuss boats and boating, from maintenance and repairs to seamanship and safety, as well as everything in between. This podcast is a companion to my YouTube channel of the same name, so if you like and find it useful, be sure to subscribe and please check out my YouTube channel as well, where you'll find hundreds of informative videos on pretty much every boating topic imaginable. Today we're going to be talking about galvanic isolators. What we're going to do is we're going to deep dive into this. We're going to discuss what exactly a galvanic isolator is, what it does, if you need one for your particular situation, and also tips on selection, installation, and maintenance. If your boat has an AC power system that's connected to a shore power and dock, it likely needs a galvanic isolator. It's a low-cost upgrade that provides protection to the vessel and increases safety for the crew. But what is it and what does it do? Well, that's what we're going to be talking about right now. Let's start by discussing galvanic corrosion. Exactly what is galvanic corrosion? Well, galvanic corrosion occurs when two dissimilar metals are immersed in an electrolyte, a liquid that can conduct electricity, such as salt water, and they're connected either by direct contact or an external wire. This creates a natural phenomenon known as a galvanic cell, where electrons flow from the less noble, more negatively charged metal, and it's called an anode, to the more noble, more positive metal, which is known as the cathode. The amount of this low-level DC current flow is determined by the metals involved, but it is typically less than 1.2 volts DC. What this flow of electrons means is that the more noble metal will be protected by the less noble metal, which will begin to corrode in the process. You can determine the corrosion pecking order of metals by referring to the galvanic series chart, and I'll post a link to that in the description below. Any boat with two different metals immersed in water, bronze props, stainless steel shafts, aluminum stern drives, etc., can act as a galvanic cell and in turn be subject to galvanic corrosion. This localized galvanic corrosion can be controlled by adding an even more active, less noble metal into the mix, which will then sacrifice itself to protect the other metals. The most common metal used for these sacrificial anodes is zinc, although magnesium and aluminum are also used depending on whether the vessel's in salt, fresh, or brackish waters. Most people know these sacrificial anodes as zinc, so that's a common name for them. Although just keep in mind that they're not always zinc. They can be one of these other metals. The surface area of the sacrificial anode determines the amount of protection, while its weight determines how long that protection will last. For example, if your vessel has a stainless steel prop, more noble metal, installed on an aluminum outdrive, which is a less noble metal, you would need to add a sufficiently sized sacrificial anode or anodes to the outdrive to protect it. If the vessel is electrically isolated from other vessels, monitoring and maintaining this system is pretty straightforward. Once the sacrificial anodes are installed, you would then monitor your vessel and the condition of the anodes to ensure that the outdrive is fully protected against galvanic corrosion at all times. When your boat is plugged into shore power, however, the AC power system green wire ground connects your boat to the marina power system and every other boat plugged into it, along with any galvanic corrosion issues they may have, or the dock. I mean, once you plug into the AC shore power system at the dock, any problems with the dock wiring or any boats along the dock or the marina connected to that AC shore power system, now everybody's connected to the same problems. This in turn can lead to problems with your own vessel's cathartic protection system, ranging from accelerated rates of deterioration of your sacrificial anodes to corrosion of the underwater metal itself. In other words, when your boat's plugged into the shore power system, any other boat that's also plugged into the shore power system that has insufficient sacrificial anode protection will naturally act as a drain to the boat that is properly equipped with adequate anodes. Let's say that you have an inadequately protected aluminum outdrive and your dock neighbor's boat is an inboard with a similarly unprotected stainless steel shaft and bronze propeller. Connection via the AC power system green wire ground creates a galvanic cell between the two vessels. As aluminum is less noble than both stainless steel and bronze, this connection means that your unprotected aluminum stern drive or outdrive will essentially act as a giant sacrificial anode, protecting the stainless steel shaft and the bronze prop of your neighbor's boat. The two methods of addressing this issue, other than not plugging into the AC shore power system, are installation of either an isolation transformer or a galvanic isolator. Isolation transformers electrically isolate your vessel when plugged into a shore power. They are typically used on larger vessels because they're big and heavy. They're also very expensive. Galvanic isolators are small and relatively inexpensive, on the other hand, making them the best option for many boats. But what do they do? I mean, what does a galvanic isolator actually do? The galvanic isolator, GI for short, blocks the flow of any low voltage DC current that may be present on your AC shore power cord, green wire, ground from the other vessels or even the dock wiring itself, preventing it from affecting your vessel. It does this while maintaining the continuity of the green wire ground, allowing any AC fault current present to flow back to the dock pedestal where it can either trip the circuit breaker or flow to ground. Some people may think, well, it seems like a good idea. Let's just cut this green wire ground and isolate my vessel. But don't do it. Without protection provided by this green wire ground connection, a fault in the AC wiring or onboard AC powered equipment could energize the equipment case, the vessel, or surrounding air and water with deadly results. Safety always takes precedence over corrosion control. So to continue on about how a galvanic isolator works, the galvanic isolator is essentially a blocking diode assembly that prevents the flow of a low-level DC along the green wire ground mentioned before. It galvanically isolates your boat from the dock and any of your neighboring boats. A galvanic isolator is installed in series with the green wire ground conductor between the vessel's shore power inlet and main panel grounding bus. The cut-on point for the GI diode assembly is around 1.2 volts DC, at which point any galvanic DC voltages present are blocked. Most all DC galvanic levels are below this 1.2 volts DC threshold. So now that we know how all this works, how do we select one? Well, what you want to do is, in general, choose a good quality marine grade galvanic isolator, one that has UL, Underwriters Laboratories, marine rating. UL rated units are certified as being fail-safe, meaning that should the diodes fail, the safety green wire ground will still be connected, ensuring a pathway to the ground exists should a AC fault occur. Galvanic isolators are selected based on the amperage rating of the isolator, in other words, the amount of current the isolator can handle under severe fault conditions. The unit you choose will be based on the system amperage of your vessel's AC circuit, which will typically be 30 amp or 50 amps. So depending on your vessel configuration, whether you have 30 amp or 50 amp circuit shore power, then you're going to choose the 30 amp unit or you'll choose a 50 amp galvanic isolator. Most galvanic isolators are rated to handle 1.4 volts DC for stray current protection. Better quality galvanic isolators also include a capacitor and are designed to pass through AC shore power voltages, typically 115 to 230 volts, and fault conditions. AC current is not normally found on the AC shore power green wire ground. However, should an AC fault occur, the ground wire and the galvanic isolator must be able to carry the full load amperage of the AC power circuit. So let's talk a little bit about installation. A galvanic isolator is installed between the grounding system of your boat and the ground wire of the shore power cable. While you want to follow the specific manufacturer's instructions provided by your unit, here are some general recommendations that can be applied to most any galvanic isolator installation. First up, turn off all AC power breakers on both the pedestal and your boat, then disconnect the AC shore power cord from both the boat and the pedestal. If your vessel has a DC to AC inverter, make sure that the unit is also secured, turned off, and disconnected. Next up, securely mount the galvanic isolator on a solid surface near the shore power inlet for your boat. An area near the inlet is usually best, as that means, for one thing, you need less wire to install the galvanic isolator. The galvanic isolator should be easily accessible, well ventilated, and protected from the environment. Once you've got the galvanic isolator mounted, you're going to disconnect the green wire from the rear of the shore power inlet. That's the plug that's at your boat. This wire will be either green or green with a yellow stripe, assuming it's properly color-coded. The galvanic isolator will have either two terminals or a wired input and output. The labeling for the galvanic isolators may vary between models, but one will be marked boat, ground, or ship, or something similar to that, while the other one will be labeled shore ground or shore or something like that. For units with terminals, connect the vessel ground wire removed in step 3 to the galvanic isolator terminal designated as the vessel ground. Then install a ground wire between the galvanic isolator shore ground terminal and shore power inlet. Many of your galvanic isolator units will come with a short section of additional ground wire that you'll need to do this. For galvanic isolators with wires, connect the green input wire of the isolator to the vacated terminal of the shore power inlet. Then you're going to connect the remaining output green wire from the isolator to the vessel ground wire you removed using a good quality marine grade connector. Note that the unit must be hardwired without the use of any friction type connections. In other words, no spring loaded alligator clamps or any of that stuff. It's got to be a good solid connection made with marine grade connectors. Then after you've got the galvanic isolator installed and wired up, neaten up any wire runs and support the wires as needed. Finally, once it's installed, you're going to test the AC power system for proper operation while verifying that the galvanic isolator is functioning properly with no faults shown. So another good thing to have with your galvanic isolator is a remote monitor. Typically, these galvanic isolators are going to be installed in an out-of-the-way place where you may be able to easily see the fault codes, or it'll have a display, typically an LED or something that shows a fault or that everything's working good. So if your galvanic isolator is installed in one of these out-of-the-way places, it's great to have a remote monitor for your galvanic isolator installed somewhere where you can easily view it. Great place is typically the main breaker panel. A remote monitor panel is critical for your galvanic isolator installed in an out-of-the-way place, because your galvanic isolator can stop working for a number of reasons, including things such as major electrical faults or even nearby lightning strikes. So it's crucial to be able to monitor this thing easily. Finally, let's talk a little bit about maintenance. Follow all your maintenance procedures for your galvanic isolator as required by the manufacturer. In most cases, this will be at a minimum. Check the unit connection for corrosion or physical damage on a regular basis, typically annually at a minimum. It's also good practice to check the remote monitor for faults anytime you plug into the shore power or after any major electrical event, again, such as nearby lightning strikes. It's not that often that a boat owner can install a piece of equipment for around $200 or so that protects both the boat and your passengers. A galvanic isolator offers both peace of mind on both fronts at a reasonable price. It's a win for everyone. I hope you enjoyed today's podcast. And if so, and you want to buy Captain Frank a cup of coffee, please click on the support link in the text description below. All monies received, not spent on coffee, will go towards making even more awesome podcasts for my channel. And as always, thank you for your support.